So that's going to be a big step forward for social presence, and I'm really glad that we're focused on making it inclusive from the start. Now, what about unlocking more mixed reality experiences? I mean, imagine working at your virtual desk with multiple screens while seeing your real desk so clearly that you can pick up a pen and write notes without taking your headset off. Or, you're doing a workout with a virtual instructor in your living room.
It's going to be so cool. We're already seeing the potentials of these kinds of experiences today as people are building for our pass-through API. But with Cambria, we'll be taking this to the next level with high-resolution, colored, mixed reality pass-through. We essentially combine an array of sensors with reconstruction algorithms to represent your physical world in a headset with a sense of depth and perspective. Now, we're still a ways away from exactly matching what our eyes see in the physical world, but we're pretty encouraged by how far we've been able to advance the pass-through experience so far.
Definitely, but we also need to push the visuals to the next level. So let's talk about the progress that we're making on optics.
Yeah, we're pushing the limits of display technology and form factor with something called pancake optics. They essentially work by folding light several times over to achieve a slimmer profile than current lenses. Now, with several optical layers, we'll need to precisely control every aspect of design and fabrication to achieve that high-quality, artifact-free display and really just deliver the best optics ever in one of our headsets.
That's pretty awesome. But let's make sure that we leave some of the good stuff for next year's release, too. All right, now, I'm excited to keep building out this new product line over future generations so we can keep getting our most advanced technology into people's hands even before we can get it into our Quest product line.
That's our goal. We're starting to work with developers to build experiences for Cambria as we speak, and we're looking forward to sharing so much more with y'all next year.
Sounds good. Now, beyond virtual reality, we are also focused on the hardware to make true augmented reality possible. In a lot of ways, augmented reality is even harder. Not just because we need to invent a completely new optical stack that's not based on screens, but because we basically need to fit a supercomputer into a pair of normal-looking glasses. So we're approaching this problem from two directions. First, how much technology can we pack into a pair of normal, great-looking glasses today? And second, how do we take the long-term tech stack to do everything and keep miniaturizing and improving it until it fits into a pair of normal, good-looking glasses? On the first path, last month we launched Ray-Ban Stories, our first smart glasses in partnership with EssilorLuxottica. They're not full AR glasses yet, but they let you take pictures and videos, listen to music, and take phone calls while you're out looking at the world instead of down at your phone. And we built leading privacy features into the glasses, like the LED light whenever you're recording, which phones don't even have. And we delivered this in the iconic Ray-Ban style for just $299. These are all steps along the path to an embodied internet. But the ultimate goal here is true augmented reality glasses, and we've been working on that too. And today, I want to show you an experience that we've been working on for Project Nazare, which is the code name for our first full augmented reality glasses. Here, you'll see you're chatting with friends on WhatsApp and planning a game night. You can select a game, and then, as you walk over to your kitchen, you can easily just put your game onto the table and you're off. And that's the kind of experience that augmented reality will unlock. There's a lot of technical work to get this form factor and experience right. We have to fit hologram displays, projectors, batteries, radios, custom silicon chips, cameras, speakers, sensors to map the world around you, and more into glasses that are about 5 millimeters thick. So we still have a ways to go with Nazare, but we are making good progress. I'm excited about our future roadmap, but even that's still early in a journey that's going to go on for decades. Immersive all-day experiences will require a lot of novel technologies. And for the last 7 years, our research team has been working on a broad array of technologies that are necessary for these next-generation platforms. Michael Abrash leads this team, and he's going to join me to talk about some of the future technology that we're developing. Hey, Michael, do you want to take everyone through our roadmap?
Sure. That covers a lot of ground, though. It's going to take about a dozen major technological breakthroughs to get to the next-generation metaverse, and we're working on all of them. Displays, audio, input, haptics, hand tracking, eye tracking, mixed reality sensors, graphics, computer vision, avatars, perceptual science, AI, and more.
Yeah, you're right. That's a lot. We probably only have time for a couple right now. You want to pick a few?
Well, I think the metaverse is really going to be first and foremost about connecting people. So I'd say let's start with avatars.
Yeah, I agree. The goal here is to have both realistic and stylized avatars that create a deep feeling that we're present with people.
Exactly, and we've shown codec avatars before.
Well, what can your face do? Can you show us?
Well, I've always hoped you would ask me that question.
And it's a remarkable experience to see codec avatars in VR, and photorealistic avatars will be a huge breakthrough. But they're only part of the picture.
Yeah, because you're not always going to want to look exactly like yourself. That's why people shave their beards, dress up, style their hair, put on makeup, or get tattoos. And of course, you'll be able to do all of that and more in the metaverse.
So this next video shows how we're making progress on part of that with hair and skin rendering and relighting for 3D avatars.
She's going for a medical field. I think she was interested into...
Now, I want to point out this technology is still very definitely research, but it shows the really high level of fidelity that avatars are ultimately going to need to reach. Notice that you can see the individual pores on his skin. Now, clothing is another important way to express yourself. And whether you want to simulate your actual garments, say you're making a quick call with your grandmother, or maybe you just want to be wearing a stylish blue Oxford shirt like me, you're going to need the ability to simulate clothing. So here's an early look at hand-cloth interaction. And you can see how the movement of the cloth when the hand touches and stretches it is really remarkably accurate.
Now, to use your avatar to teleport to a meeting or sit down for a chat in the metaverse, you'll also need realistic virtual spaces to be with people in. So let's look at that. Contrary to how this looks, this is actually not a video of the physical world. It's a 3D reconstruction of a mock apartment, which I guess just became clear when that bowl took off by itself.
Exactly. So what you can see here is that a researcher is moving around various objects on the right, and then on the left you can see the high-fidelity real-time rendering of the space in the moving objects on the left without the researcher. So what's critical here is that this is all happening in real time. That's what's novel here, and that's what differentiates it from CGI. So what we've seen so far is pretty awesome, but we all know what we want. We want the whole package, a full-body avatar in a virtual environment, so you're just there. Last year, we showed our very first full-body codec avatar at Connect. Here to tell you more about our progress since then is Yasser Sheikh.
Hi there. My name is Yasser, and I direct the Facebook Reality Research Lab in Pittsburgh. Well, that's not completely true. What you're seeing is actually a rendering of my pre-recorded codec avatar. Over the past couple of years, we've made quite a bit of progress with codec avatars. My avatar can now look left, look right, look up, look down, make facial expressions.
Here, you can see Elaine is in VR on the right. You can see her view of Yasser's avatar and the reconstructed real-world space that it's in on the left as she moves around the avatar. What you see on the left is an entirely virtual reconstruction. This gives you a sense of a future in which you'll be able to interact with another person's realistic avatar in virtual reality in real time. Now, preventing others from using your avatar will be critical. That's why, even though this is early stage research, we're already thinking about how we could secure your avatar, whether by tying it to an authenticated account or by verifying identity in some other way.
All right, so